Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 4. It says a wooden box slides down a rough 8-meter long inclined plane AB. The initial velocity of the box at A is 2 meters per second, as shown in the diagram below. Then 4.1 says define a conservative force. Now, conservative force is a force for which the work done in moving an object between 2 points is independent of the path taken. Right. Then let's go to 4.2. It says name the conservative force in the diagram above. Remember, conservative force can either be the gravitational force, or you can say it is the normal force. So either one of these two is correct. Right. Then 4.3 says state the work energy theorem in words. So to state the work energy theorem in words, we say work energy theorem states that the net work done on an object is equal to the object's change in kinetic energy. Okay, now we have 4.4. It says the velocity of the block at point B is 6.92 meters per second. Use energy principles only to calculate the frictional force that the block experiences as it moves from point A to point B. Right. So now what we are supposed to do is we can use the work done by non-conservative force, since we have the frictional force, which is a non-conservative force. But then we know that in order to use this formula, WNC is equal to change in EK plus change in EP, we would need to know the height. But then at this point, at point A, we don't know the height. But we also know our trigonometry. So we can just close off here so that we form a right angle triangle. And whenever you are trying to calculate the height, when you are given the angle theta and then also your displacement here, which is the hypotenuse, is just to mainly say height is equal to sine theta multiplied by delta x. So now you have your sine 30 degrees multiplied by your delta x, which is 8. So note this. Whenever you want to calculate the height and then you have theta and delta x, that's how you calculate the height. And then this will give you 4 meters. So your height here will be 4 meters, right? So this is a necessary manipulation. Then let's continue. We can say that the only non-conservative force that is present in here is the frictional force, because there is no tension, there is no applied force. So we will say this is work done by Fk, and then we just continue breaking down the formula here. This is half m Vf squared minus Vi squared plus mg height finally minus height initially, right? So this is work done by Fk is equals to half. Our mass is 2 kg, and then our final velocity at this point, we've been told at point B the velocity is 6.92 meters per second, so 6.92 square. And then our initial velocity at point A, we can see it's just the 2 meters per second. Then we have our mass again 2 multiplied by 9.8. Our height finally, when it reaches point B, will be 0 because that's on the ground. And then height initial is the one that we just calculated, it's 4, right? So please do not make a mistake of substituting your height as the displacement there. It is not the same thing. Then when you punch all that into your calculator, you get a negative 34.51 joules, right? And that's supposed to be the way you calculate your work done by the frictional force. But then note here, they said to calculate the frictional force, right? So if they said to calculate the frictional force, that means you still need to go further with this. So I kind of did not realize that. I'm seeing it now. So that means we still need to continue here and say 34.51. Then we have our Fk, our delta x is 8. then cos 180 degrees is equals to negative 34.51. We divide both sides by 8 cos 180, which is just negative 8. So 8 cos 180. Then our FK, let's find out. So we have negative 34.51 divided by negative 8. So this will give us a value of 4.31 newtons. Yes, that's how you were supposed to calculate that. So essentially, you could have just broken it down from this formula here, but then it is all still one in the same thing, right? Okay, then let's continue 4.5. 4.5 says the coefficient of friction for the last horizontal stretch after point B is 0.35. Calculate the distance the block will travel before coming to a complete stop without using equations of motion. Right. Now, one thing that we do understand is that the friction on the incline and the friction on the horizontal surface will not be the same, because remember, your friction depends to your normal force. So here, while it's sliding down, we say the normal force has a smaller magnitude as compared to when it's now moving horizontal. So obviously, we expect the frictional force in here to be larger than the frictional force on the incline. Hence, they gave us the 0.35 here as our coefficient, meaning we should not use the friction that we just calculated in 4.4. We are supposed to use this coefficient in order to calculate the new friction on the horizontal stretch. Now, the first thing that we're going to start by doing is try to draw a free body diagram representing all the forces that will be on the horizontal stretch. So we have our FG, and then here we have our frictional force. So remember, there is no applied force, and then when it's moving on an incline, there is no FG parallel, right? So the only force that will be representing the W net here is your frictional force. So since now it's on a horizontal stretch, I like to just go with W net is equals to change in EK. Since I won't be using that one because we do not have any relative height. So it's your change in P will just be 0, which it's the same as your W net is equals to change in EK. Now, your W net, remember, is only represented by work done by FK, and then this is equals to change in EK. Now, at this point, what we want to do is we want to break down this. This is FK delta X, then cos theta is equals to half M VF squared minus VI squared. But then pause. We don't have the magnitude of FK. We only have the coefficient. Now, a lot of you make the mistake of substituting the coefficient into FK. The coefficient of friction and friction is not the same thing. Remember, the coefficient of friction multiplied by the normal force is what gives you your kinetic friction from this formula here. So FK is equals to mu K times N. What you are given from this statement is not the FK, it is the mu K, it is this one. Right. Now, what are we going to do in order to calculate that? From our free body diagram here, we can see that, oh, the normal force is equals to the gravitational force because this is on a horizontal plane. Right. So now that we know that our Fn, or our normal force, is equals to Fg, that means we can replace our N here by mass times gravitational acceleration. So our mu K and then times M times G. Right. So this is 0.35. Our mass is 2, and then our gravitational acceleration is 9.8. So if we multiply the 2 here, this will give us a value of 6.86 newtons. So now we have the value of Fk. That means now that we have the value of Fk, we can just continue with the formula and substitute our magnitude of frictional force in this formula here. So this is 6.86. But what are we looking for? We are looking for the distance. It says calculate the distance the block will travel before coming to a complete stop without using equations of motion. So this is only restricting you to using the energy principles if it says without using equations of motion, right? So that's another way to say using energy principle. Then to come to a stop, that means your VF is 0, right? Okay, cool. Then we have our delta x. This is cos 180 degrees. That's half. Our mass is 2. Our final velocity is 0. It comes to rest. But then what is our initial velocity? It will have to be the velocity at point B, because the horizontal stretch starts from point B. So at point B, we were told that the velocity is 6.92. So 6.92 square here. Now, when we calculate this, that's negative 6.86 delta x. And then doing all of this will give us a value of negative 47.8864. So I'm not rounding off anything. Now I'm dividing both sides by negative 6.86, negative 6.86. Then our delta x, the distance, will now be 6.92 meters, right? And that's how you were supposed to calculate this question for a total mark of 13. So make sure that you play the video as many times as possible and try to understand the approach that I took into solving these questions. But with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.